Our next unit after that of design is going to be implementation. And this is typical in the software lifecycle as well, is once we have the design, we can start working on implementing or actually coding the thing. So we're talking about implementation. Now, this entire unit isn't going to be as in-depth as the other ones because implementation is very specific to the technology you are using. So if you're creating a online app, it's going to be very different than if you're creating a mobile app, or very different than if you're creating a back-end server application that talks to financial institutions and never interacts with the front-end user. There are 1,000 different ways that you can implement something. And therefore, like I said, there isn't a lot that we can talk about here that wouldn't be really specific to a certain type of problem. So what we're going to go over is just some of the core tenets, and then a lot about deployment and that sort of area, because deployment is sort of a theoretical area and there are some mistakes you can make in there, some things you can learn there. So let's go over some of the tenets of programming. One of the main things that you should do, or that the company should be doing, is to take care of the programmers. That is very important because implementation is where most of the time is going to be spent. And if it's poorly implemented, then it's where basically most of the time can be lost too. If you have the most amazing design document in the world and your programmers don't design it like the document, well, it doesn't matter that you spent all that time on design, because now you have a product that is just as inferior as if you didn't spend it on design. And so what you need is you need to have your programmers alert and focused. You need to have them focused on the task at hand and thinking of the best solutions as they go forward. Because even though our design might be pretty in-depth, we don't have some of the nitty-gritty designed yet. And there are still choices that can be made within this. There's still very poor choices that can be made. And what we get is this thing called technical debt that keeps coming back up. So if we start building up more and more technical debt, it's going to take more time later on to fix it. So if we save 10 hours now, it might take 100 hours later on to fix that 10 hours that we saved right now. And so we can kind of think of it like this: 35 hours of programming a week. Typical work week is like 40 hours, so 35 hours of really focused programming can be just as productive as 70 hours. So if you have your workers, working till 8 o'clock at night every night, really trying to get something out, it's probably, you might be able to push the date that, maybe instead of releasing way over here, it releases, a few days earlier. However, the amount of problems and the amount of fixes you're going to have to do to get it to that optimal state, it's going to cost way more time later on to fix that. So keeping this in mind is that just because you add more hours, it doesn't make it more quote unquote productive, is very important. And programming takes focus. Constant interruptions will reduce the overall focus. So if you're at a company and your company is constantly calling meetings, maybe that's something that needs to be brought up. Maybe the production overall can be quicker if you don't go to meetings all the time. If you're allowed to have, maybe a 4-hour block in the beginning to really just sit down and focus on coding. And if you're maybe self-employed, or if you're working for your own apps, then you need to keep focus yourself. You need to make sure, you don't deviate off into social media or watching YouTube videos, that you keep yourself very focused on the task at hand. And then some coding principles. These are just sort of a set of principles that you should keep in mind while implementing. And that's: use a style guide so all the code looks relatively the same. This is very important if you have multiple different people working on a same project. Imagine something like Microsoft when they're working on the OS systems. Imagine if every single programmer put their own little style spin on things. You would have code that every single file is different and therefore hard to understand. And it can come down to simple as, if we say a function, so if we have like function that accepts a parameter A, do we put the curly brace on the same line and then the end brace down here? Or do we always indent and put the curly brace like that? There are 1,000 of these little decisions, and a style guide will help make sure that the code all looks the same. Therefore, it's easier to read and easier to get people up to speed on the code. Code is written for people, not computers. That is something very hard. That's something very important to understand, and a lot of computer programmers don't get this concept. They try, it sort of goes in with this one too: shorter code does not equal better code. A lot of people take it as sort of a pride thing if they can write a function that could have been 7 lines of code, and then they try to write it in something like 3 lines of code. They try to use some really complex, function of A of B times 6x3 of, multiply by 9, 7, stuff like that, where it goes on and on and on, and it's a single line function, where they could have actually broken it up into a really nice, readable expression that someone could jump in and be like, oh, okay, so we're taking this function, then we're adding 3 to it, then we're dividing the amount of taxes they have to pay and multiplying it by their gross income, something like that. And so they can be like, oh, okay, this function is doing that. Where with this one, they're like, I'm not entirely sure what this is doing. And if there's no comments to tell you what it's doing, then this function is basically a mystery. It's a black box that this programmer is now going to have to throw data through. They either put some input data in and then put some output data to figure out what the heck is going on. And so why was this implemented? What's the purpose of implementing it like this then? It didn't save any time. These are both equivalent. It makes it harder to read. And overall, it just makes maintaining it harder. So there's no point in making it as concise as possible like this when you can. Now, you do want to keep it concise, but when you can make it just a little bit more readable, always err in the side of more readable. Make modules easy to learn and understand as well. So again, this goes back to the modularity things, the coupling, the decoupling. Whenever you're programming, if you have to come up with a new some different methods, some different classes all acting together, then make sure that you make them easy to learn and easy to understand. Make them, high cohesion, low coupling. Make it so I can look at it and I can immediately say, oh, okay, that's dealing with our payment information. That's dealing with, that's dealing with the user information. That's dealing with the user itself, something quick like that. And then finally, we want to break up our actions into methods. We were talking about modularity a lot where we have these big modules. However, inside the modules, typically we have these things called methods. If you haven't taken a programming course yet, these methods are basically like little functions within a module. And we want to make sure that we create enough of these methods and we don't code duplicate. So if we're doing the exact same task in this function and this function and this function, maybe instead of copying and pasting it in 3 places, we create ourselves a new method so that it makes it more readable over time. But overall, we want to create code that is for people. We want to create code that is readable. We want to create code that is easy to maintain and easy to bring additional people on because we want our program to succeed. And if our program succeeds, we might have to bring more people on to keep up with maintenance and adding new features and such. And if we have very poor code, that's going to be impossible. And even though our program succeeded, it's going to fail over time because we can't keep it moving. So that is some just the core tenets of implementation. And now let's sort of jump into a little bit of the deployment thing, because that's important, is how to deploy our software properly so that we can either back it up or we can basically predict some of the bugs that might come out and make it as pain-free as possible.